In this video, I'm going to show you how to create a Toon Shader or Cell Shader. This is a little bit of a departure from these realistic materials, and the methods are slightly different, though everything is done in the shader graph. So in terms of the way that we work, it's not going to change in any way. So I'm going to create a new shader graph, and this time I'm going to select the unlit shader graph. I'm going to call this Toon Basic, and let's open this up. So the difference that you'll see in an unlit shader graph is that there is only one fragment output, and that is the base color. So any calculations that we need to do for normals and such have to happen before we hit fragment, okay? Because they're not going to be done at runtime, or they're not going to be done live, right? So any normals and stuff we've got up for an object need to be calculated and blended with the color before it goes, before it leaves the shader, as it were. So with that in mind, the setup for a simple Toon shader is quite simple, and these shaders are unlit, which means they're not going to be receiving any lighting information. So what we'll do is we'll have a look at this without any lighting information. So we'll look at the unlit shader as it is. Okay, so let's create a new material that is using our Toon shader. Let's call this Toon material, and I'm going to change the shader to my Toon Basic that I just created, and let's drag this on. And you'll see that there is very little information here. There's a little bit of ambient occlusion going on, and that's probably being conducted by our global volume. Global volume is contributing to it, certainly, but there is some general ambient occlusion happening on the object, and there's probably a bit of baked lighting in the scene as well, which is fine. So this is only really showing us one value, right? One color, and we're not getting any shadows behind the object and all that kind of stuff. So how do we calculate this? If the shader is unlit, it means it's not receiving any lighting information. So how do we receive lighting information and interpret it in the way that we want for this shader? So this is fairly simple. A couple of years ago, you used to have to code HLSL for this type of stuff, but increasingly, as these systems, as these node-based systems are becoming more accessible to people without the expertise to be able to do that type of stuff, more and more nodes get created that allow people to do stuff without coding. And some of you will be familiar with the blueprint system, for example, in Unreal, and some of you will be familiar with visual scripting in Unity as well. And they kind of simplify these. They abstract the complexity into something that's very accessible, and this is no exception. So in the last couple of years, you've started seeing nodes that help us to produce this type of shader, and the one we're going to look for is we're going to do a quick search for light, and specifically what we're looking for is this. It's under the subgraph setting, and it's called Get Main Light. Okay, so we're going to use this, and what we're going to do is we're going to perform a calculation where we compare the main light's direction to our normal direction, or the normal vector on the mesh. So we see if they're facing the same way, essentially, or if they're facing the opposite direction. So we're going to go onto normal, and we want the geometry normal vector. There we go. And to compare them, we're going to use something called a dot product, which is explained in more detail in one of the handouts that I've uploaded. But the dot product is able to compare two vectors and essentially give us the difference between them, okay? Or at least not necessarily the difference, but to establish whether they're in the same direction or not. So this is the resultant output from our dot product calculation, and what we're going to do is we're just going to lighten it up a little bit with an add node. So we're going to take this in here and I'm going to add 1 to the result, and you'll see that this lightens it up considerably, but hopefully you can see that there's still a shaded area over here. This is just a node that I'm adding out of experience of working with this shader. This is sort of thing like as you're experimenting yourselves, you'll go, well, yeah, this isn't working quite right. Is there something I can do to brighten this up? And this is, as I was just figuring out the best way to show you how to do a Toon Shader, I decided that this was a necessary node just to brighten up the results. Additionally, something to increase the contrast as well is desirable, and I'm using a multiply node for this. And I'm just multiplying the result by 0.5. You can experiment with different results and see what the effect is. So what the multiply does is you'll see it just it spreads the darker spot out a little bit more, essentially. Okay, so the next step is that what we want to do is that this is essentially getting the lighting information, getting the main light. It's establishing where it's hitting the surface, and it's establishing which areas of the surface should be lit and which areas of the surface should be shaded. Now, what we're then going to do is we're going to use this to sample a gradient map. All right, so we're going to bring this up here, and I'm going to type in sample. Actually, let's do this the other way around so that it's a little bit more intuitive. So the first thing I'm going to do up here is I'm going to create a gradient node. Okay, and there are two types of gradient that I'm interested in here, or two types of node related to gradients that I'm interested in here. One is the gradient, which is the gradient itself, and then just like when I'm working with a texture 2D data type, I would need to sample it, and this is how we sample a gradient. So we've got a sample gradient node here as well, which we'd need to use after we've created our gradient. So first of all, I'm going to create the gradient. So this is what our gradient looks like, and if you click on the gradient, you can bring up this editor over here, and what I'm going to do is I'm going to create a gradient which is in a fixed blend type. What this means is there's no interpolation between the different values, and I'm going to locate some different values at different positions in this gradient. Okay, so I might run out of values here actually, so I need to just maybe have this one here. Okay, that one needs to go at 25. I guess we can just do it approximate, can't we? And this one is going to be about 50. Okay, and what I'm doing here is I'm just going to set up the gradient for the shading. So this one's going to be like a dark grey. This one's going to be probably a black, although we tend not to shade to black if we can help it. So let's have that at just a very low value. There we go. And then this one here, we will have as a lighter grey, something like that. And this one, again, we don't normally have white if we can help it. We'll pull it back a little bit, something like this. Okay, so we've got a nice linearly interpolated or step interpolated, sorry, gradient here. Okay, and now we need to sample it. There we go. And when we sample a gradient, because a gradient isn't the same type of data as an image, we generally sample it with a single value, a single float between 0 and 1, and that value is called time, or t, quite often. And so if I type in like 0. If I type in, well, it's 0 at the moment, and you'll see our resultant value is this dark grey that we selected. If I type in 1, then it will go to this one. If I type in like 0.3, it will go to this one. And if I type in 0.6, it should go to this one. Okay. Now, what we're going to do is we're actually going to use our lighting information to select which color should be used. Okay. You see that that gives us this really nice sampled gradient. Okay. And then what we can do is we can just plug this straight into our fragment base color, and let's save this and go back into our scene, and you'll see we've got some shading on our object. Now this shader sphere is not the best really for looking at a Toon shader, to be honest, but you can see we get a nice result right away. Okay, it seems pretty effective. Let's add just a standard sphere in here as well, so we can have a look at it on a standard sphere. Okay, Toon material, there we go. Alright, so that's pretty much as we would expect it to be. Now then, what if we want to be able to colour this in some way? We don't want to be having to jump back into the shader to colour it ourselves, right? So what we'd like to be able to do is control how this works within the material itself. So we want to be able to control this parametrically. So the best way to do this is probably with a lerp function. So we're going to select lerp, and in fact I'll just create it up here without connecting anything. Alright, and what I'm going to do is I'm going to add some input colors into here. So let's grab a color here. So I'm going to say this one is the highlight color. And we're going to call the next one the shadow or shade color. Okay, like this. Alright, so we've got two different color inputs here, and what I'm going to do is I'm going to connect these up. So I've got my highlight color is going to go into the second one here, and my shade color is going to go into the first one. And I'm going to use this to lerp between them, and then the output will go into here. So let's save that out. And we can set, I think we can set this up as a default actually, so we can change this out a little bit, and we can actually see the result in the shader itself. So let's change this. So what I've done here is I'm just selecting these options and I'm changing the defaults on them, and this allows me to see the results within the shader graph. Okay, so you can see we get these really nice results here. Let's save that. Okay, and then because I'd already added them before I did the defaults, like these have come through as black essentially. So what I'm going to do is just create them. So this is the highlight color, right? So let's make it orange here, or yellow, something like this. And then the shade color for yellow is quite often a deep sort of red, something like this. Okay, so let's go and have a look at what this looks like. Really nice. So you can see how you can achieve something that's kind of Zelda-esque with this type of feel, like Breath of the Wild-ish, or even like a Mobius type illustration. Okay, so that's really quite effective. Now what we can also do, if you really wanted to, is we could start blending this in different ways with textures. So let's bring all this graph a bit further over here, give myself a bit more space. I'm going to add in our texture 2D. Okay, so base color texture, just leave it like this. I'll bring that over here. And this kind of like the early Borderlands visualizations, I think probably the actual, like the first Borderlands used this type of method, although I think the early Borderlands might have used different texture types for each shading value. But what we're going to do is we're going to sample that, and then we're going to let's bring this down here, and we're going to add a blend. Alright, like this. In fact, we could do this the other way around actually. So we can make the image the blend, and we can make the color the base, like this. And what I can do here is I can set a default color, which we haven't done yet. So this is quite a neat technique because it allows you to see what it's going to look like in the shader graph itself. So let's set a default, and we'll just look for our stone material. Okay, so this is the resultant material. I don't think our preview is going to work on this, which is fine. And we can choose different blend modes, so we can decide like how it's going to blend with each different. So we can choose how it's going to blend with the color essentially, and just have a tinker around with it and get to a point that you're happy with. Generally what I find is the best one is either soft light, like this, that kind of brings that color through, but you can also see the texture, or overlay, which is the default. Now you do find a lot of people using multiply, and the things with this is it kind of retains a lot of the original darker details, which we don't necessarily want, because remember our darkest areas are meant to already be shaded in this kind of red color, so we don't necessarily want to do that really. So let's have a quick look at this one, and I'm sure that you will come up with more novel applications for this, but let's add our stone shader in there. Okay, so we're not actually getting any results at the moment, so let me have a think at why that is. It's probably because I haven't connected it up, and I haven't. So let's finish it off, add that into the base color, save the asset, drop back into the scene. Yeah, that's definitely not what I want. But you can see how each of these values is interacting with the texture in a slightly different way. So let's go back in here and change the blend mode, maybe to soft light. That tends to work quite well. Okay, and that's probably a little bit more like a Borderlands type of style. So the texture's still there, but you've got this really kind of cell shaded look over the top of it as well. It's almost like a wood block print in a way. Let's have a quick look at how this looks on a cube. Bring it over here. Okay, and then we can spin it around. Yeah, so you can see how that reacts in different ways according to the direction it's facing in. Alright, so that's a basic Toon Shader, and you can of course blend this or synthesize this with the triplanar function, which is really, really cool. So that's when you start bringing in like, you know, completely non-UV mapped assets and being able to create this type of Toon Shader with them. Now, the next step for this would be to create an outline shader. So if any of you are interested in that aspect, then just let me know and I will shoot a video for that, or run a specialist online or in-person session for you to learn about how you might go about doing that. We can continue to tinker around with this. We can reduce the number of colors in the gradient, we can increase the number of colors and all that kind of stuff. So there's plenty of stuff that we can do to work on this gradient. We can also modify the points at which different lighting comes in. So we can really tighten these up on this end if we wanted to. Okay, generally you would have it, rather than being spread evenly, you would have this kind of setup where the highlights are only appearing on the most light areas. So let's just save this and see what the result is. And there you start getting these kind of highlights on the edge. It's not particularly aesthetically pleasing in this case, but yeah, you'd probably play around with these and get them exactly right. But this tends to be a bit closer to what the types of setup we have, because otherwise your highlights are just too large. So let's just pull that back a little bit like this. And have another look. Yeah, that's a little bit more like it. Okay, right. Yeah, key takeaways are that we need to sample the main light, because if we're using an unlit shader, then we don't have any lighting information. So we need to get the information from the main light, and we need to compare that to the normal vector of the object in world space to determine the dot product. Okay, or to, you know, we determine the dot product of those. So we do a comparison between the direction of the main light and the direction of the normal vector. And then these are some math functions that I'm just using to brighten up and increase the contrast as well. So brightening up the resultant data and then multiplying it to get a bit of contrast in there. I could have just done a contrast node. And then here we've got the gradient that I created. The standard method would normally use an image for this. So you would normally use an image that you've made in Photoshop or whatever. You'd make your gradient in Photoshop, but I quite like doing it this way because it just means that I can come in here and change it without jumping into Photoshop, which I don't use. So this tends to be a far better setup for me. And then we need to sample that gradient, and then we're using this gradient to lerp between the shade color and the highlight color, which gives us this lovely gradient on our three-dimensional sphere. And then I showed you how you can blend that with a texture color as well to get a sort of borderlands type effect.